And then if there is a critical point, you need to classify it. So in order to find out that, you always find out the Hessian matrix and find out the determinant of it. And if the determinant is greater than zero and your x coordinate, your x double differentiation is greater than zero, then it's a minimum. If this turns out to be less than zero, the second part, then it'll be a maximum. If your first part itself is less than zero, then it's a saddle point. Any doubts in this question? If you understand this, like, you should be able to do literally any of the other questions in this exercise. I'm just going to solve one more, just to get familiarized with this, and then we can like, I leave the others for you guys to try. But if you guys have doubts, I can definitely do that. I'll check the Zoom. Okay, there's nothing on the Zoom. Yeah, it's quite important that you know how to solve this question. I'm pretty sure like he'll ask something around this in your exams. It's a pretty standard question. So let's solve the seventh question. My f of x comma y is 3x squared plus 2xy plus 2x plus y squared plus y plus 4. So first things first, in order to find out the critical point, my dou f by dou x, let's see what it is. It is 6x plus 2y plus 2 equal to 0. Then my dou f by dou y will be 2x plus 2y plus 1 equal to 0. Solving for these two equations, I will get my point as minus 1 by 4 comma 1 by 4. Okay. So once you know this, we'll try to find out the Hessian matrix. The Hessian matrix will be, the first term will be double differentiation of this with respect to x, which is 6. If you differentiate this with respect to y, it's going to be 2. The same thing, this term will be 2. If you differentiate this with respect to y, it will be 2 again. So if I find out the determinant of h, it's going to be 12 minus 4, which is 8. Okay, now we have the determinant is greater than 0. And my dou square f by dou x square is 6, which is also greater than 0. Now combining both these conditions, I can tell my point minus 1 by 4 comma 1 by 4 is a local minimum. Is it clear? Any doubts?
After you take the Hessian matrix, you take the second derivative of just x, right? Just to see if like the conditions are met.
Yeah, like if you consider this as 1 and this is equation 2, in order to find out this term, it's basically differentiating equation 1 with x. In order to find out this term, you differentiate the first equation with respect to y. This is going to be the same value because they are the mixed derivatives. And in order to find out the last term, it's your equation 2 with respect to y.
Right, that makes sense. But like you got the determinant of the Hessian matrix, and then like that like right below where you did the Hessian matrix, you did the second derivative of like
Correct.
x equaling 6, which is greater than 0. Is that like just you checking, or is that just another step?
So this is another step. This is like a condition.
Okay.
So you go back to the last notes. You always need to find out both the conditions. So if you see here, I always need to find out my determinant, and I also want to find out what is my double differentiation with respect to x. Only with these both, I can classify with some minima or a maxima. Only for saddle point, like when you find out the determinant, if it is less than 0, you can immediately term it as saddle point. It doesn't matter whether your second derivative with respect to x is like less than 0 or greater than 0.
Okay, got it. Thank you.
Okay. Okay. So all of the questions are just very similar. I can probably do, let's see, I'll probably do, okay, I'll do question 8. I'm assuming 9 can be done by you guys. 8 and 9, they look similar, just like the sign and the cost terms are different, but and also the critical points are different. So I'll try to do 8. 3.3.8 f of x comma y is sine of x squared plus y squared. And then they're given themselves that the critical point is 0 comma 0. Okay. And they're just saying consider this is the only point and find out whether this particular point is a maximum or a minimum. So they just want us to classify this. So let's see what's the first derivative. My dou f by dou x is 2x cos of x squared plus y squared, which is equal to 0. And then my dou f by dou y, it is going to be 2y into cos of x squared plus y squared equal to 0. Okay. So I'll also try to find out what is my second derivative. So because I want to find out my Hessian matrix, so my second derivative is dou square f by dou x square is, so this, if you try to write it down in terms of d by dx of like you have, it's like you can take this as u and this as the v term. So if you try to differentiate uv, it's basically like u dash v plus u into v dash. So I'm going to use that particular rule in order to differentiate this. So you'll get it as 2 into cos of x square plus y square minus 4 into uh, x square into sine of x square plus y square. Okay. Now let's see what is the same exact thing at the point 0 comma 0, because they've already said 0 comma 0 is a critical point. I'm going to substitute x and y as 0 and 0. So I get it as 2. So from this, I got like the first term in my Hessian matrix. Similarly, I try to find out what is my other terms in the Hessian matrix. And based on the Hessian matrix and this particular term, I can classify the point. So let's see what is dou square f by dou y square. So this is again going to be 2 cos x square plus y square minus 4y square sine of x square plus y square. Same thing at the point 0 comma 0, it's going to be 2 again. So I found out two terms. Let's try to find out what's the mixed fraction term. So which is dou x dou y, or it's same as dou y dou x. Let's see what this comes on to. This is basically when you take this particular thing and when you differentiate with respect to y, I am going to make use of the same thing. So we'll get as minus 4xy into sine of x squared plus y squared. So this point at 0 comma 0, it's going to be 0 because my sine of 0 is 0. So knowing these values, my final Hessian matrix is just 2, 0, 0, 2. And if you find out the determinant of this, it is 4, which is greater than 0. So, and we also have my first term, which is also greater than 0. Since my determinant is greater than 0 and my first term is greater than 0, I can say that my 0 comma 0 is a local minimum. Does it make sense? All I'm just doing is finding out the second order derivatives with respect to x, y, and then xy. and I'm trying to substitute it at the point 0, comma 0 that's given in the question, and you can find out the Hessian matrix. So similarly for question 9, you do the same method, except that you have like 3 critical points that you have to consider, and you have to classify each of the 3 critical points, um, and based on whatever we know. So I'm assuming question 9 can be done. Question 10 again is very similar. Like you find out the critical points, and then you classify each of the point. 11 is similar. 12, 13, 14, 15. Actually, all of the other problems are very similar. I'm just going to follow the same method for all problems. So, yeah, do we have any doubts or questions? Because I don't have anything else that I want to specifically show. I can take up doubts in any of these problems if you guys ask for it. Hello. Can you speak up clearly?
Yeah, 1 second.
Okay, in question 7. Okay.
I think he said 1 second.
Oh, 1 second. Okay.
Can you hear me better?
What is it?
Can you hear me all right now?
Yeah.
Yeah, I can hear. Yeah.
Perfect. Okay. I had a question on it was the unit that we did before,
Uh-huh.
2.6.
Okay.
On 2B.
1 second. Let me just navigate there.
All right.
2.6. Okay.
So it
On
asks us, yes.
Okay.
So it asks us to take the derivative of a log function.
Mm-hmm.
And I remember you doing one of these in the other homework.
Uh-huh.
And I was wondering how you derive the log function.
Okay. Okay. Okay, this is 2.6.2 and B part. So you have your f of x comma y is log of root of x square plus y square. And the point that's given to us, x naught, y naught, is 1, comma 0. And then the vector that's given to us is 1 by root 5 times 2I plus j. Okay, so the derivative of log function, how do you generally do it? So let's see what is the derivative of d by du of log u. So d by du of log u is just 1 by u. Okay, now in this case, I have my u as root of x squared plus y squared. So if I do in similar ways, my d by dx of log root of x squared plus y squared, it is going to be 1 by the same, like 1 by root of x squared plus y squared, into the differentiation of what's present inside the log. So in this case, it's root x. So we know that differentiation of like root x is 1 by 2 root x. Okay. So this is going to be 1 by 2 times of x squared plus y squared into the differentiation what's present inside the root terms. So differentiation of x squared plus y squared with respect to x, it's just going to be 2x. So
Question.
Yeah.
Are you interpreting log as natural log? I thought the interpretation was log base 10.
It doesn't really matter. I think you can just take it as 1 by u.
You just get a constant term.
Yeah, yeah.
Okay, because I guess my big thing, I understand this is how it works now. Previously, I would have thought that the derivative of the log function was 1 over natural log of the base times u. but sounds good. That was just my only question.
Okay. Yeah, I think this is how it looks.
Perfect. Thank you.
Yeah.
So the derivative of lack of log is like 1 over u times u prime, right?
Correct.
Okay.
Any other questions? Let me just check how much people have submitted the homework already. Let's go. Okay, only 2 people have submitted. Okay. Yeah, there's probably a good number of problems this time. So probably everyone are taking it till the last day.
Could you do problem 9?
Problem 9?
Yeah,
In this
3.3.
3.3. Okay.
Yes. Because I got the age is gonna be 000 something, so I think I did something wrong.
Yeah, we'll figure it out. Question 9. Okay. Okay, 3.3 or 9. So you have your f of x comma y as cos of x squared plus y squared. And then they're saying that there are 3 critical points for this, which is 0, 0, root of pi by 2, comma root of pi by 2, and then 0, comma root of pi. So the question is to just classify each of these critical points as a maxima, minima, or a saddle point based on what we have. So so if you take this, let's differentiate this with respect to x. So you'll get it as minus 2x sine of x squared plus y squared. If you differentiate it with respect to y, I'm going to get it as minus 2y sine of x squared plus y squared. So if you differentiate this with respect to x again, in order to find out the Hessian matrix, so it's dou square f by dou x square is minus 2 sine x squared plus y squared minus 4x squared cos x squared plus y squared. The same way, if I differentiate this, I'm going to get it as dou square f by dou x dou y squared is minus 2 sine x squared plus y squared minus 4y squared cos x squared plus y squared. And if I differentiate this with respect to y, I'm going to get it as dou square f by dou xy is minus 4xy cos x squared plus y squared. So we have all the 3 terms that we are looking for in our Hessian matrix. Now all that's left is to substitute at the points that are given for each one of the critical points and find out what's going to be the Hessian matrix. So let's take first the point as 0, 0. So let's see what is dou square f by dou y, dou square f by dou x squared at point 0, 0 is going to be 0 because you have an x term here and the sign of this is going to be 0, so it's going to be 0. And this is also going to be 0 and this is also going to be 0. So literally all of my Hessian matrix looks like something like this 0, 0, 0, 0. So my determinant is also 0. So this is the place where your second derivative test actually fails. Like you cannot still classify it as a maxima, minima, or a saddle point. So so this is where basically my second derivative test fails. So so we just go with like one of the properties that in the given function, like if I just substitute the point 0, 0 and if I get like a positive value, then I can classify it as a maxima. If I get so whenever second derivative test fails, you find out what is f of x naught y naught, where x naught y naught is a critical point. So if this one is greater than 0, then it's a maximum. This one is less than 0, then it's a minimum. Okay. So let's see what is the value of f of 0 comma 0. So f of 0 comma 0 is cos of 0, which is 1. And since this is greater than 0, my 0 comma 0 is local maximum. So this is one important thing to know. You can have this as the property. The next one is let's take the point root of pi by 2 comma root of pi by 2. So we need to classify this point. For this, you'll again see like what happens if you substitute here. So you're going to get x squared plus y squared. So x squared plus y squared is something like pi by 2 plus pi by 2, which is pi. So let's see what happens if we substitute pi here. So this term is going to be 0, and this term is going to be minus 1. But your second, even when you like use this kind of when you find out the Hessian matrix for these points, again you'll find out your determinant kind of turns out to be 0. Like I'm not going to do it. Like you can figure out that by figuring out the terms and substituting here, you'll also find out my determinant of the Hessian becomes 0, and here also your second derivative test fails. And once it fails, we fall back to this kind of property where we just find out what's f of root of pi by 2 and root of pi by 2. So let's see what if we substitute here. So you'll get it as cos of pi. So this is cos pi and this is minus 1. Now since minus 1 is less than 0, this point is a local minimum. Same way, if you do it for the point 0 comma root of pi, you'll again find out my determinant of the Hessian becomes 0, and you'll end up finding out what is 0 comma root pi, and this is cos of again pi, which is minus 1 less than 0. So this point is also a local minimum. Does it make sense?
Yes, thank you.
Yeah. Let me just check if there is an example that has where your second derivative fails and you try to follow this kind of condition. I haven't checked this out, but it should be there, I guess, somewhere. Now you guys can probably see the examples. If there is an example where your second derivative fails and they see on how to find out the maximum minimum based on this kind of property. Okay, do we have any other question? Okay, I'll check the Zoom chat. Okay, there is something on the Zoom. This homework is very long. Yeah, I agree. It's a pretty long homework, especially with all the parts and stuff. But yeah, like there'll be some homeworks that are this long. You guys, not sure if I can do anything regarding that because it's the professor who has given the problems. Uh, yeah, like, just try to finish it off only for this time. Okay, 2.6.2 part C. I'll check what is that. 2.6.2. Okay, yeah, asking for the C part. Okay. Okay, 2.6.2 part C. You have your f of x comma y as e power x cos of pi y. You have your point x naught y naught as 0 comma minus 1, and the vector is minus 1 by root 5 times I cap plus 2 by root 5 times j cap. Okay, let's try to find out the directional derivative of this. So directional derivative if is before that we try to find out what's the gradient. So that my gradient is going to be this with respect to x differentiation, which is e power x cos of pi y. And the same thing with respect to y. If I differentiate, I'm going to get it as minus sine pi y into pi into e power x. Okay, this is my gradient. Let me try to find out the gradient at the point that they're asking for, which is 0 and minus 1. So if I try to find this out, it will be minus 1 and 0. So my directional derivative at the point 0 comma minus 1, it is basically my gradient at the point 0 comma minus 1 multiplied with the vector that they are given. So this is a dot product with the vector that they are given. So this is minus 1 comma 0 dot product with minus 1 by root 5 comma 2 by root 5. So this is just plus 1 by root 5. And that's your directional derivative. Any doubts in this question? Thank you. Okay, any other doubts? I think this next topic will be pretty interesting as well, where you try to use this Lagrange multiplier method. Yeah, this is a pretty good method, and you can literally expect a question from this as well in your exam. Where so this is a kind of uh, topic where they kind of give you some constraint equations, and then they try to ask you like what how do you maximize a particular f of x function given these are the g of x constraints. So that is how you kind of solve these conditions. Like if you take this example, like you have this find out this extreme points of this particular f function subject to two constraints. So there is a method of doing this, and this would be like the majority of next homework, I think. Let's see how much problems are there. Yeah, in your next homework also, I think we have something similar like this. This will be nice, and I think this is probably the first kind of topic where you actually will do a bit of more geometry. You'll try to draw the curves if they are given, and then see which areas are the intersection points, and these are the areas under which you have to do the differentiation. So this will be good. This topic would be good. Okay, if there are no more doubts, then we can probably wrap up today's session. Um, okay, thank you for joining. I'll see you guys next week.